Today we will be doing the chemical properties of metals. Now children, you know metals are electropositive in nature. They are electropositive. Electropositive means we write the symbol Na plus, Ca2 plus, Mg2 plus. How they get it? How they become electropositive? By losing electrons. Na loses electrons to form Na plus. It loses electrons. So why it is going to lose electrons? Because sodium in the outermost shell is having one electron and it is having an excess electron in the outermost shell. To become stable, it will lose this electron to form a stable configuration, that is 2,8. Hence it is electropositive. Similarly, magnesium, it loses 2 electrons to form Mg2 plus. Now the question comes, why Mg is going to lose 2 electrons? You write the electronic configuration 282. The atomic number of magnesium is 12. The atomic number of sodium is 11. So you can see it here, 1 electron is excess in the outermost shell. Here 2 electrons is excess in the outermost shell. Now it will lose these 2 electrons to become a stable electronic configuration. Now I think you got it. That metals, they lose electron to attain stable electronic configurations and hence they are said to be electropositive in nature. So metals are basically electropositive in nature. How they are electropositive? You got it, the idea. Now these metals, when it reacts with oxygen, alright, when it is heated. Now when it reacts with oxygen or when it is being heated, when it is reacted with oxygen means it's being heated, then only it is going to react with air or oxygen. It reacts differently under what you can say different conditions. It reacts differently. Now what do you mean by that? That it reacts differently. Now here I am saying, listen carefully. When sodium is being heated in air, alright, it ordinarily, just you take sodium outside, you know that sodium is highly reactive metal. For that reason sodium is kept inside the kerosene. It is being kept inside kerosene. So when you take out sodium from that kerosene and you bring it in air, it reacts under ordinary conditions. It catches fire after some time. So sodium is highly reactive in nature. It catches fire. It burns with a dazzling I'm saying, it burns with a yellow light. Sodium burns it. When it burns, sodium in ordinary, that is air, it burns with a yellow light. Sodium, it gives a yellow light. Alright. Why it gives a yellow light? Because sodium reacts with oxygen to form. Air means oxygen, it is heated in air or oxygen to form, that is nothing but sodium oxide. 2Na plus O2 gives nothing but Na2O. So it will be 4Na instead of 2Na. I will be writing it to balance it. So what I said, it burns when sodium is heated, when it is brought in contact with air. Simply you bring it in contact with air. After some time you will see sodium burns to give you sodium oxide, which is nothing but a yellow flame. A golden yellow color flame, you will be getting it. Got it now? Listen carefully. Sodium, ordinary conditions in air. Now, after that you come to magnesium. Alright. Now, if you take magnesium and if you burning magnesium, you have to take it. Listen carefully. Burning magnesium, you have to take it and you put it in a gas jar of oxygen. It burns with a dazzling white light. Remember it. It burns the dazzling white light to give a white residue, that is magnesium oxide. Magnesium, burning magnesium, if introduced into a gas jar of oxygen, it burns with a dazzling white light to give a white residue of magnesium oxide. This is white residue of magnesium oxide. So here it is in ordinary conditions. Here under burning condition, it burns. Got it? Here also it burns, but in ordinary conditions. But it burns when you are taking hot magnesium. Listen carefully. Now, after that, I come to zinc. Now, zinc reacts with oxygen, alright, to give a blue color light. It gives you to form zinc oxide. Zn plus O2, 2Zn plus O2 gives 2ZnO. It burns with a blue color, what you can say, light. It gives a blue color light. It burns. Alright, here it burns. But it burns not, I am not taking, what I am saying is that here here I am taking heated magnesium, here I am taking ordinary sodium in air, but here what I have to do is that I have to heat it for a long time. Little bit time I have to heat it, and then only it is going to burn to give you zinc oxide, which is blue color flame you will be getting it, a blue color light you will be getting it. Listen carefully. Now iron I will be taking it. After that iron, I take a iron wire, let us say iron metal, it's a wire, I will be taking it and I will be heating in presence of oxygen. Now it is not going to burn. Iron is not going to burn in presence of oxygen. Rather it is going to give it to you Fe3O4. Fe3O4 is what? Triferric tetroxide of iron. 3Fe plus 2O2 will give you Fe3O4, triferric tetroxide. But it's not going to burn. I'm saying you, it's not going to burn this one. Fe3O4. Iron is not going to burn. Iron burn only in blast furnace. Alright, it melts there. And it's not going to burn. It's going to give you Fe3O4. Now, let me tell you here about Fe3O4. Fe3O4 is a mixed oxide. It is considered to be as. Why it is mixed oxide? Because it is made up of two oxides, FeO and Fe2O3. In FeO, the valence of iron is +2. You can see ferrous oxide, and Fe2O3, the valence of iron is +3, ferric oxide. So hence it is said to be a mixed oxide because it is made up of two oxides, FeO and Fe2O3, Fe3O4. Okay, it's a mixed oxide. Clear? Again I repeat, it does not burn. Now copper. Let us come to copper. Now copper, when it is heated in presence of air or oxygen, when it is heated. Now you have to heat it copper for a long time. You have to heat it. It's not going to burn at all. For a long time you have to heat it. Then what you'll find, it forms a black residue of copper oxide. 2Cu plus O2 gives 2CuO. So what I come to it, that sodium under ordinary conditions, when I bring it in contact with air, after some time it catches fire and it burns the golden yellow light. Magnesium, under hot magnesium, it burns the dazzling white light to give a magnesium oxide a white residue, burning magnesium. Here zinc, I have to heat it for a long time and it burns with a bluish, what you can say, flame or a bluish light. Here it does not burn, it gives you triferric tetroxide. It is also called as magnetic oxide of iron, and here it does not burn at all. Here you have to heat it for a long time to give you a black color copper oxide. So hence, what we get it? In terms of reactivity, this is highly reactive, sodium. Then what you get it? Magnesium, because sodium under ordinary, magnesium burning. Then what we get it? Zinc, because zinc burns at least to blue flame, and this does not burn at all, iron, and copper though not at all, we can say that. So hence what you get it? This is the reactivity series of the metals we get it. The reactivity series which you have studied in the lower classes, you might have studied the reactivity series of the metals. Alright, so in this way we prepare the reactivity series based on the reactivity of the metals. You can see in front of you it is there. Based on the reactivity of the metals, we get this particular series. Understood now? Hence we have prepared this series. The sodium, you can see vigorous. Under ordinary conditions, it catches fire. Nothing you have to do it. You have to just bring it in presence of air. So hence the reactivity series we are getting it. So by this, what you can say, reactivity of the metals in oxygen, we get a reactivity series. That sodium is more reactive than magnesium, is more reactive than zinc, is more reactive than iron, is more reactive than copper. Alright, and based upon that, we are having a reactivity series. Alright, that is, I have made a poem to remember the series, the whole series in this way. Popular scientist can make a zoo, I am rubbing in this one for the time being, in the low humid country more satisfactory. Potassium, sodium. So what I said, popular scientist can make a zoo in the low humid country more satisfactory. I have taken the first letter and I have made this poem according to the Indian system. Don't say, sir, it is potassium. Yeah, it is popular for that reason. This natrium, no, it is not natrium, sodium. Any sodium here. The popular scientist can make a zoo in its iron, the tin, low, lead, humid, hydrogen, country, copper, mercury, much satisfactory silver. This is the metal activity series. You can remember the point. So how we have made this series? On the basis of this, we have made the series. I think you got it now. How to remember the series? I told you the poem also, and you came to know about the reactions also. Now the question comes, next question, that how metals forms oxide, or why do they form oxide, metals? Already a part of the answer I have given you in the beginning. A part of the answer. What is that, a part of the answer? I said that metals are electropositive in nature. Oxygen is electronegative in nature. How? See here, magnesium, it loses 2 electrons to form Mg2+. Just now I said it is electropositive. Oxygen on the other hand, it gains 2 electrons to form O2-. Why oxygen will gain? Because the atomic number of oxygen is 8. So electronic configuration is 2,6. It has got deficiency of 2 electrons in the outermost shell. It has got deficiency of 2 electrons in the outermost shell, you can see that. So hence it gains these 2 electrons to form what? 2, 8. Alright, stable configuration. Here it is what? What I said you? 2, 8, 2. It is having excess 2 electrons. And hence it forms what? 2, 8. So rather I can say the 2 electrons which magnesium loses, it is gained by oxygen. The 2 electrons which magnesium is losing, it is gained by oxygen. Got it? That is Mg2 plus O2 minus to give you what? Mgu. In this way, oxides are being formed. This is how the oxides are being formed. We can say that it loses 2 electrons and here it gains that 2 electrons to form magnesium oxide. Similarly, sodium, potassium, calcium also the same thing. Now, if you see the reactivity of this particular, or if you see the nature, first let us see the nature, then we'll go for the reactivity with water. So, if you see the nature, then you'll find sodium, potassium, calcium, magnesium, they are all basic in nature. Alright, if you take the nature of, what you can say, zinc oxide, if you take the nature of aluminium oxide, then they are amphoteric in nature. Amphoteric. Now listen carefully, children. Sodium, potassium, magnesium, they are all calcium, they are all basic in nature, basic oxide. And one more thing I'll tell you here. When the basic oxide dissolves in water, it forms an alkalis. So what are alkalis? Alkalis are soluble bases. That is, when sodium oxide dissolves in water, alright, or potassium oxide dissolves in water, what it gives you? It gives you NaOH. Alright, it gives you 2NaOH. Now this is soluble in water. This is an alkali. This is an alkali, it is soluble in water. So sodium hydroxide, potassium hydroxide, ammonium hydroxide. Alright, they are water soluble. They are alkalis. Sodium hydroxide and potassium hydroxide are alkalis. They are the soluble bases. And the bases which are not soluble in water, they are simply known as bases. So for that reason, all alkalis are, what you can say, bases. But all bases are not alkalis, because all bases are not soluble in water. But let me tell you again, sodium oxide, potassium oxide, calcium oxide, magnesium oxide, they are known as bases. Alright, they are called as bases. Okay, basic in nature, they form basic oxide. Now, aluminium oxide, zinc oxide, they are amphoteric. Amphoteric in nature, they are amphoteric oxide, they are said to be as. Why it is called amphoteric? Because it is known as amphoteric because it reacts with acids as well as with bases to form salt and water. Like you can see it here, zinc oxide reacts with acids H2SO4 to form ZnSO4 and hydrogen. Same zinc oxide will react with NaOH to form Na2ZnO2 plus H2 hydrogen. So here you can see zinc oxide reacts with sulfuric acid. Zinc oxide reacts with bases. This is zinc sulfate, this